This lecture is going to go over covalent naming, which is different than ionic. So it is important for you to be able to differentiate between the two of them without being told this is ionic or this is covalent, because at the end of the unit, you're going to have to be able to decide those things on your own. So how do I decide if it's covalent or not? If it's covalent, it does not contain any metals or ions, meaning it's all nonmetals. So thinking on your periodic table, you're looking off to that right side of your staircase. So it's important for you to be able to identify what's a metal, what's a nonmetal, what's an ion, because it's only going to contain nonmetals. So our first step here when we're naming this is we're going to name the first element using the name of the element. So if the first element in your covalent bond is carbon, you're going to call it carbon, okay? Easy enough. The second element is named as an ion, so using IDE. So remember all of those things on that right side, your nonmetals end up being your anions in any bond, your metals or your cations. So we're going to name the last element in your bond as an anion. And the other thing you're going to use is those prefixes that you had in your ion packet, the ones on the front page. You're going to use those to tell how many of something you have is. So if you have 2 of one element, it's going to be di. If you have 3, it's going to be tri. So it's important for you to know those as well. And then something just to keep in mind, the prefix mono is never going to be used with the first element, this one here that we're naming with its name. We're never going to use mono in that situation. So best thing for us to do here, go over some examples. Dinitrogen hexafluoride. So I think the first thing that's important to do, especially when you first get started doing these, is to identify what elements we're looking at. So we're looking at nitrogen and we're looking at fluoride, which we know is fluorine because it got changed to IDE, okay? So we know that we have nitrogen, so we can go ahead and put our N down. We know that we have fluorine, so we can put our F down. Now what we have to decide is how many of each of these do we have. So di means we have 2. Hexa means we have 6. So instead of our numbers or our prefixes going in front of them, they're going to go in as subscripts behind. So that means dinitrogen hexafluoride. And you're done. Okay? So let's go here. Let's look at the next example. Silicon, that is our first element. Bromide came from bromine. So we can go ahead and write those down. S, and then we have a Br. So now determining how many of each of them we have. So we can put our our subscripts in there. Silicon, there's nothing in front of it here, which means we have 1. So this was that example I told you where your first element is not going to have mono in front of it. It's just going to be by itself. So we can just leave that as it is, because if you don't have anything in this spot, it just means that you have 1. So we're going to leave that blank. And then tetra means 4. So we have 4 bromines. Okay? So we have sulfur dioxide and nitrogen trichloride. So looking at our element here, we have sulfur here. Oxide comes from oxygen. So our S for our sulfur, O for our oxygen. Now we got to determine how many of each. How many sulfurs do I have? That means 1. There's nothing there. Di is 2. All right. So I don't have to put anything for the sulfur because there's 1. No number implies that there's 1. Di means 2. So I can drop my 2 down here. All right, go ahead, try this next one, the nitrogen trichloride, on your own. Come back and we'll have an answer for you. All right, so here's what you should be looking at for nitrogen trichloride. Nitrogen comes from our nitrogen element. Chloride comes from chlorine, 3 chlorines, so that should actually be kind of a subscript. We'll rewrite that for you. More of a subscript than up with the actual letters. All right, so now we're going to go backwards. So we went words to symbols, and now we're going to go symbols to words. So first thing we have to do here is look at our 2 elements. So our first one is an N. We know that's nitrogen. How many N's do we have? There's no subscript, which means there's 1. So for our first one, we can just write it out as is. Nitrogen. Second element is an O. So that's oxygen, but remember what you have to do with that second one is change your ending to IDE. Oxide. Oh, sorry there. And then looking at the 2 here, your prefix for 2 is di, so we write that in front. So this is nitrogen dioxide. All right, taking a look at our next one. C. What's C? Carbon. There's only 1, so no need for a prefix. Br is bromine. Change your second to an IDE. So bromide. Then taking a look at how many bromines we have 4. Prefix for 4 being tetra. Carbon, tetra, bromide. Okay? All right, I'm going to let you do these 2 on your own. Go ahead, pause the video, come back, and we'll check your answers. All right, let's take a look at this first one first. So CO, you should have got carbon monoxide. And now, if you wrote monoxide like this, monoxide, you're probably thinking, that looks really funny. So if your anion or your second element starts with a vowel like oxide and you're doing mono, what you can do is you can just drop one of these O's. So see what I did here, and just go straight from MON to what you're looking at here. Oxide's where you're going to see that a lot. You can also see that with your iodides as well. All right, so the next one we have here was PF5. So P, you should have been thinking phosphorus. Oh, my things went away here. So phosphorus, and then prefix 5 is penta, and then fluoride, ending in IDE. Okay. 2 more examples here. I want you to try these as well on your own. There's no such thing as too much practice with these. So pause it, come back, and we'll have an answer. All right, so here's some answers for you. Diphosphorus trisulfide. And then trisilicon dioxide. So as you're going to go through these, you're going to think this is very easy, this is very easy, this is very easy. However, I do not want you to get in the habit of thinking that everything is covalently named. You need to be able to identify these are covalent because these are nonmetals bonded together. Whenever you see a metal, whenever you see a polyatomic ion in a compound, it is not named covalently. Okay? So do not name it with your prefixes. Okay? Go ahead, work on some practice problems. Good luck. Let me know if you have any questions.